Hey everyone, and welcome to my second tutorial video where today I'm going to be showing you how you can create a sprite system. This is the second video in the HTML5 Canvas and JavaScript for web games tutorial series. In the last video we looked at how we can use HTML5 Canvas and JavaScript to create very simple web animations, and in this video we'll look at how you can create a sprite map. In this video we'll be building on the code from the last video, so if you didn't see that, I do recommend you go and check that out first. In preparation for creating this video, I created a simple sprite map of my own containing 5 sprites, each of them 100 by 100. You can have however many sprites you like, whatever size. You can use any image editing software to make them. I've created a simple falling man animation. He's kind of flailing his arms around a little bit, and eventually he splats on the floor. The first thing our code needs is a new class. That class is the entity class, which you can see has two methods. Firstly, the constructor, which will build the entity, and secondly, the drawSprite method, which will draw it onto the canvas. I've also created a simple variable called testEntity, which is an instance of the entity class. We'll use this to test the methods as we add them. We'll start with the constructor. The constructor has 4 simple parameters: the x and y positions of the entity, as well as the entity's width and height. Then we simply use the this keyword to assign those as properties of the entity object. We need to store the image data of the sprite map within the entity object, and to do this I am using the HTML image object constructor, which we can use the ctx.drawImage method to draw onto the canvas. Returning to the constructor of our test entity, I'm going to specify some basic properties for it so that we can test it in our browser. Now inside of the browser I will open the index.html file, which still has our green square from the last video. Open the inspector, and going into the console we can write test entity to log the test entity, and we can see that it has all of the properties for which we specified. Now we can begin on our drawSprite method. Firstly, we'll give it 3 properties: the sprite number, as well as its rotation in degrees, and whether or not we want it to be flipped. In order to make the coming code a bit more concise and a bit more readable, I've also shortened all the variables to simple names like x, y, and ctx. In order to rotate and flip our sprite, we'll be using context transformations. In order to understand how these work, we'll be visualizing the canvas as a set of 2 axes, x and y, and the context as a grid on top of the canvas. Unlike in most simple planes, the origin, which is the point that has an x and y of 0 in the canvas, is not in the bottom left. It's actually in the top left. So a y of 0 will be on the top row of pixels. The context has 3 transformations. The first and most basic one is translate. Translate takes 2 inputs, the x distance and the y distance. The translate method simply moves the axes or canvas some distance x and y relative to the grid or context, effectively changing the origin. The second transformation method is ctx.rotate. The rotate method takes in 1 parameter, which is the angle in radians. Radians is a scale of measurement for angles, just like degrees is, except instead of measuring angles between 0 and 360, instead it's between 0 and 2 times pi. We can visualize radians by drawing a circle and then cutting out a section of that circle. The ratio between the circumference of that section to the diameter of that section is the angle in radians. It isn't important that you remember that though, because our drawSprite method takes in an angle in degrees and will convert to radians when it becomes necessary to do so. All the rotate method does is rotates the context of the canvas around the axes of the canvas. It rotates around the origin, 0, 0. Finally, we have the scale method. The scale method takes in 2 parameters, the x scalar and the y scalar. For every position on the context, the x coordinate is multiplied by the x scalar, and the y coordinate is multiplied by the y scalar. This means that by scaling by numbers larger than 1, we can grow the context. By scaling by numbers smaller than 1 but larger than 0, we can shrink the context, or by multiplying by numbers smaller than 0, we can simply flip the context. Multiplying by 1 is obviously going to do nothing. If we try to rotate our character using the draw sprite method, it'll be rotated around the origin. This will not only rotate our character, but also move it in unexpected ways. Instead, we'll rotate the entity around its own center. We need to remember that the x and y properties of the entity don't refer to the center of the entity. Instead, they refer to the top left. To get the center of the entity from the top left, we can add half of the width of the entity to the x and half of the height of the entity to the y. The new x and y coordinates will give us the center of the entity. In the example, the entity is located at 100, 100, and we know that its width and height are 100 and 100, which means that the center of the entity is at 150, 150. Since the rotate transformation rotates around the 0, 0 position, we need to move our context so that 150, 150 is at 0, 0. To do this, we can write ctx.translate 150, 150 to move the origin directly under the center of our entity. We can express this more generally as x plus 1/2 times the width and y plus 1/2 times the height. Now that the center of our entity is positioned over 0, 0 on the canvas, we can use the rotate method to rotate it 180 degrees or pi radians around the origin. If we were to draw onto the context now, we would have our entity located at the coordinates 0, 0, which is not what we want. So after rotating, we need to reverse the translation we did before, simply by adding negative signs. Finally, we need to restore our transformations to the status quo so that next time we want to rotate something, we don't end up stacking our transformations on top of one another. Rather than having to write all our transformations in reverse, luckily the context has some special methods that can help us. ctx.save saves the transformations of the canvas in its current state. ctx.restore restores it to the saved state. ctx.restore should come after the draw image statement. Flipping an image is a similar process. In our sprite system, we'll only be allowing you to flip the image over the y-axis, but it would be easy to introduce compatibility for flipping over the x-axis as well. Because we're keeping the y coordinates the same, we just give it a parameter of 1, and because we want to flip the x coordinates, we give it a parameter of -1. However, there's something wrong with the current state. As of right now, the center of our entity, which is currently located at 150, 150, would be scaled to -150, 150, which is not on the canvas. Once again, we need to scale so the center of our entity lies on the origin, this time only for the x-axis. This means that for both of our translations, backwards and forwards, we'll simply have our y-coordinate as 0. Our function is nearly ready, but as you can see, it is still missing two things. Firstly, our rotate parameter is empty, and secondly, we haven't done the drawing yet. We can convert our angle from degrees to radians by finding our angle out of 1 by dividing by 360, and then multiplying by math.pi times 2 to get it in radians. That simplifies to simply degrees divided by 180 times math.pi. Finally, we draw the actual image. The first parameter is the HTML image object, which in our case is this.sprite image. The next two parameters are the coordinates x and y from where we want to take the smaller image inside the bigger image. Since our image is portrait, the x is always going to be 0, and for each sprite that we want to take, it is sprite num times the height. The next 6 parameters are very easy. Firstly, the size of the cutout that we want to take, which is just the width and the height. Then the position that we want to place it on the canvas, which is just the x and the y. And then how big we want to scale it to, which is just normal size or the width and the height. I finally moved our complete method inside of the draw sprite in the entity class. I've only made 2 small changes. I've simply made a default value of 0 for degrees. And I've also made flipping conditional. I've also slightly modified the drawer object by adding a new property called frame number, which starts at 0 and is incremented by 1 every time the update function is called. I've also created a new constant called gravity, which will quite easily allow us to modify how fast our character falls. And since we're no longer animating a simple green square, I've removed the x and y variables from the drawer object, and everywhere else they'll be replaced by the x and y properties of the entity object. Before setting the interval for the drawer update function, I've created a new instance of the entity class called falling man, which has a x position of 200, y position of 0 or the top of the screen, and a height and width of 100, which matches the size of our sprite. Now we just need to set his source. In order to do that, we need to make sure that our sprite map is inside of our code folder, and we need to remember its name. Now make sure to correctly enter the source of your image, and don't mess up or it'll throw a big error. Now I've updated the update method of our drawer object with all the logic needed for my animation. The first thing I do is check that if we update the falling man's y position, he won't have gone through the floor. Then if that is the case, we update his y position. Then we draw his sprite. We draw it with the sprite number as the frame number modulus 4, meaning that it will loop from 0 to 3 for each frame. And we put his rotation as whatever his y coordinate is, modulus 360, meaning that as he falls, he will loop through each rotation. Now I put the required logic in to handle once he does actually reach the floor, in which case we draw him exactly the same, except that his sprite number is always going to be 4, or the 5th sprite. Before testing our code, I'm just going to move all of our code that runs at the start to the bottom to make sure it has access to all the other functions. The one last little change I need to make is to make sure that we are writing this at the start of frame number, because frame number is a property of the drawer object. So now we can return to the browser where we can drag and drop in our index.html file. And as you can see, our little animation works, and we can configure our gravity to make him fall slower. We can configure his animations to make them look more realistic or more cartoonish or whatever we want. And we can play around with this and eventually even add some game logic. I'd like to thank you guys so much for actually sticking around all the way to the end of this tutorial, and I really do hope that you learned something and enjoyed. I hope you go off and make your own web apps, and I hope you also subscribe so that you can come back for the next tutorial. See ya!